All righty. So as you take a look, guys, we are finishing up chapter 8. So we cut chapter 8 into two parts. Okay, we did the first part, which was addition and subtraction of like terms. We did some multiplication, some foiling, some distributive property. And now we're going the other way. So if we've done addition, subtraction, and multiplication, what's missing? Division. And we call division with polynomials factoring. All right. Have you guys heard of factoring before? Yes, no, maybe so? Oh. You guys know how to Dougie, right? You guys know how to Dougie? Ever heard that song before? Teach me how to Dougie. Yeah, remember that one? Teach me how to factor. Teach me how to factor. Everybody factor. Everybody factor. Show your whoop when you factor. Oh, yeah. What's up, bud?
I was here for a test.
You're 5 minutes late.
Yeah. Right.
Put your phone there, and then you can go in the back corner.
All right.
Today, Junior. Thanks, bud. In the corner would be great. All right, here we go. We got factor, and we got what's called the GCF. So we're going to find prime factorization of a factor. And goal number 2, we're going to find the greatest common factor. That means the biggest number that they have in common. Okay? All right, so a little vocab. First up, prime number. You guys heard of prime numbers before, right? What are prime numbers? Colton.
I think it's any number that's divisible by 2.
That's even numbers. But good guess. What's a prime number? What type of numbers are prime?
1.
1's a prime number. Okay, what else?
5.
5's a prime number. Let's list these guys. 1's a prime number. So what's a prime number? Will?
Number that the only way to get it by multiplication is by multiplying the number in itself.
All right, so again, so it's divisible by 1 and itself only. So like 6 is not a prime number because you could divide 6 by 2 or 3, right? Does that make sense? So 1 is considered a prime number. 3 is considered, I heard 3. I heard 5.
7.
7. 8.
9.
9. 10. 11, right? I heard 13. Yes, sir. 14.
15.
15.
19.
17. 19. Yes, sir. What else? 21. 22. 23.
29.
24. 25. 26.
26.
26 even, so is an even number prime?
27.
Even number is always divisible by 2, right? 23, 24, 25, 26, 27, 28, 29.
Wait, what 27 do you divide
3 and 9. 3 and 3. And then let's stop. Give me 1 in the 30s. 31. 33 is divisible by 3, right? 37. 39. It's 39. We'll stop there. That's quite a few. Now, there's one that we're missing. Does anybody know the last one we're missing? There's only one even number that's considered prime. Right? No, not 0. Good guess. Gail.
42.
No. Good guess. 2. 2 is the only guy that's even and prime. Okay. You said 42.
No, I said 1, 2, and 3. When I started
Oh, did you say 2?
Yeah.
Oh, well, Gail's got it.
I don't remember.
I don't remember him saying that, but hey, I'll give him credit. Good job, Gail. Good job, Noah. So, again, most numbers are prime or odd numbers except for the number 2. 2 is the only even guy. Okay? So this is just a list. There's many, many more, like 61. 61's a prime number. Okay, and we could keep listing and listing, but for the most part, these are the ones you would want to know. Okay? A composite number is a whole number greater than one that is not prime. So you could go ahead, yes.
1, 0, in like their own category.
1 and 0. No, 1's still a prime number. 1's prime. Yep. And 0 is kind of in its own little category, right? Because everything's divisible. Actually, everything is not divisible by 0, because if you divide by 0, it's undefined. Okay. Composite number is a whole number is greater than one that is not prime. So not 2, not 3, but 4 is a composite. That's 2 and 2, right? Not 3, not 4. We have 5, 6, not 7, 8, 9, 10, dot, dot, dot. And you could just list all of these ones that are not prime numbers. Greatest common factor is the product of the prime factors common to the integers, and we'll explain that here in a little bit. So the first thing we're going to do is example 1, we're going to find prime factorizations of each number. Here's the idea. If I take the number 4, okay, I break that down into two numbers, 2 and 2. All right, so we would say the prime factorization is 2 times 2, or 2 squared. Okay. So I'll give you another example. Let's say I had 26. Well, what's 26? If it's even, you can always divide it by what? By 2. So I use what's called a factor tree. I go 2 and 13. And then we would say that's 2 times 13 is our prime factorization. Okay. All right, so I use factor trees as I break this down. So let's take a look at 2 hundo. So we want to break down 2 hundo. Now, the way you might do it might be different than the way somebody next to you. Okay. So what's one way to divide 200 by? Damien? By 2. Now the guy next to you, Gail, might do 20 and 10. Right? And maybe Lauren does 4 and 50. You can break it down different ways, but as long as you're breaking it down correctly, you should get the same answer. Okay? So 2 is prime, so now we work on 100. Let's break down a hundo. What's that? 2 and 50. Now we work on 50. What's that?
25.
2 and 25. And then what is that? 5 and 5.
Yeah.
Okay, so then what I have is 1, 2, 3. So that's 2 times 2 times 2, or 2 cubed, either way. And then 5 times 5, or times 5 squared. Either one of those I would accept on a quiz or test. You can write it all out like this, or write it as squareds and cubes. And let me zoom in a little closer so we can see. I know that can be a little small with those exponents. Okay. All right, so let's hop on over to 650. We don't need to do all these today. So I take my calculator, 650. Okay, I go ahead and divide.
325.
What is it?
325.
325 and what? 2. So divide by 2 and you get 325. Okay. Now if it ends with a 5, it's always divisible by 5, right? So go ahead and divide by 5. What is 325 divided by 5? This is where you need your calculators out. What's 325 divided by 5? What do you guys get? Calculators, help me out. What's 325 divided by 5? 65. All right. Well, 65 ends with a 5, right? So that's divisible by 5 also. So what's 65 divided by 5? 15. I'll be okay with that. And then 15 is what? 3 and 5. Usually when we list out our prime factorizations, we start with the smallest numbers and work their way up. So what's the smallest number here? What do we got? We got a 2 here, okay. There's only one of those. Then I have a 3, right? Yes, sir? Ivan?
I said 13.
Oh, you said 13? I thought you said 15. I'm sorry. I'm not paying attention here. You said 13, guys. So 5 and 13, not 15. My bad. That would be 75. So I have 5 and 13. So again, we have a 2 here. And then I got 2 5s here. So I'm going to go 5 and 5. And then I see a 13. So then we have 13. So I'd accept this. Or if you want to write it like this, 2 times 5 squared times 13. That works also. All right. Any questions with that? Once you guys try D, 168. Try that one right there. Break this guy down. We'll skip over C unless we need it. We'll try that one. Just doing prime factorization. This is where you just take your calculator out and you start dividing out. No, you got a question, bud?
For example A, do you have to do the multiplication sign, or could you just put them together?
I usually have something separating them. So the question is, do you have to have a number? What do you need between them? I usually use the dots. You could use parentheses. But if you don't, if you just put 2, 2, 2, then that looks like 222.
I'm saying like 2, 3, 5, 2. And 2, 2, 5 squared, you just put them right next to each other.
That's what I'm saying, is if you write it as 2, is this like 2 cubed times 5? Is that what you're saying?
Like 2 cubed times.
I would have something in between, whether it's parentheses or usually we see some kind of symbol in between. There's my calculator. So again, I want you to try 168 real quick. But yeah, usually you'll see it separated with dots or parentheses around those numbers. All right, let's do this, huh? Kai, you got 168. How'd you break it down, Kai? Divide by 2. So what's that? 84. Okay. And then you broke it down how? Okay, so that's 42. And then what? That's 2 and 21. And then what, 3 and 7? You guys good with that? So as I look, I've got 1, 2, 3, 2. So I got to write that. 2, 2, 2. Or if you want to write it as 2 cubed. Then I have 3 and a 7. Or you can write it as 2 cubed times 3 times 7. This is called prime factorization. Either or, I would accept either one of those. Now you might have done it differently. Maybe you did 168 and you divided it by 4. Or maybe you divided it by 8. Just as long as that you're breaking it down correctly, you should get the same answer. Raise your hand if you got that answer. All right. Give me a thumb. Where are we at with prime factorization? Thumbs up. Do we need to see another one? JP.
So for B, I broke it down to where it was 2. Okay, so I broke 1.
So you did 168, right?
Yeah, 168.
All right, let me write it. 168, you wrote what?
And then I broke it down to 2 and then 84.
Okay.
And then I broke 84 down to 4 and 21.
Uh-huh.
Then I broke that down to 3 and 7.
Well, we got to break down the 4 too, right?
Yeah, I forgot that part.
You just forgot the 4. Now, that's great that you see that, and you're like, hey, I didn't get what you got. I got 2 times 4. Well, we can break the 4 down. Double check before you circle your answers. Double check that you don't have any what we call composite numbers that are not prime. Okay, so good. So we'll break down 4. We got 2 and 2, so there's those 2 times 2 times 2 or 2 cubed. Yeah. Okay, Damien.
So I tried C again. Is 21 a prime number?
21 is not prime. We're divisible by 3 and 7. So that's where if you get 21, you're like, okay, what can I do? 21, grab your calculator, right? Is it divisible by 2? No, obviously it's not. Is it divisible by 3? Oh, yep, perfect. If I tried 5, I'm going to get a decimal, so that's not divisible by 5. So use your calculators as a resource. Okay. All right, now sometimes you guys might have negatives here. Well, what do you do when you have a negative? Well, the first thing I do is I'll factor out the negative. Okay, so I'll do -1 and then 210. And now I just do what we just did, break down 210. How do you want to break that down? Divided by what? 2? All right, what do you get? So we got negative already taken out. So we got 210 divided by 2. What's 105? And we break that down. That is not divisible by 2. What is it divisible by?
5.
We divide by 5 and we get 21. And 21 is divisible, right? That's 3 and 7. Perfect. So again, I got a -1, so I'll write that there. That's times the next lowest number. What's the next lowest number? 2. So I got that guy. There's only one of those. Then 3. Then 5. And then 7. So I got -1, 2, 3, 5, and 7. So if there's a negative, just go ahead and factor out that negative. All right. Do you guys need to see B? You feel like you get the idea if there's a negative in front? We're okay, so we can skip over that. So I don't want to waste all your time. I'm trying to give you some homework time. Well, now we're going to start dealing with letters. We call those variables, right? So we're going to look at each thing individually. We're going to look at that 45. We're going to break that guy down. Well, what's 45 divisible by? By 5. 45 divided by 5 is 9. And that's tree and tree. Then we have an a squared. Well, what's a squared? Break that down. A squared is just what two things multiplied together? A and A. Same thing with b squared. B squared is just b times b. So if I write this out now, I got a 3, I got another 3, and I got a 5. So I got 3, 3, and 5. Now I got an A times an A, and then a B times a B. So again, as you're writing out this prime factorization, you want to break those guys down, lowest to highest, alphabetical order. A comes before B, so I listed my A's before I listed my B's. All right. All right, then we take a look at B. Now we got 77 AB squared. All right, well, let's break down 77. What's 77, y'all? Okay. Divide by 7, we get 11. Perfect. A is just A. You can't break that guy down other than A in itself, so that guy's broken down all the way. And then I have B squared. Well, we know what B squared is, right? BB. So that's 7 times 11 times A times B times B. All right. So we're kind of going backwards where we were. All right. We did some multiplication in the last unit. Now we're going with division. Now we're going to do goal number 2, which is looking for the greatest common factor. GCF. Greatest common factor. So they're going to give us 2 or 3 terms, and they're going to say, hey, what is the biggest or greatest number that they have in common? Okay, now some of you can look at 40 and 60 and you can kind of guess what is the biggest number that these two are divisible by.
No,
No? Who thinks they know what the biggest number that these two are factorable by or divisible by? Okay, 20. Now some of you guys it's easy to see right away, and some of you it's not. So this is how you do it if it's not crystal clear, but the GCF here is 20. How do you do it if you're not sure? Well, look at each number individually and break it down. Okay? All right, 40 breaks down to what? 4, okay, you could do 2 and 20, or how about 4 and 10? And now that's 2 and 2, and that's 2 and 5. And now 60, let's break that down. 6 and 10, 2 and 3, 2 and 5. Okay, so now I've got this down all the way. If you need to write out the prime factorizations of each, what I usually do is once I have my factor tree, if I'm not really clear on what the greatest common factor is, I'll have my factor trees and I say, okay, let's start circling. Okay, so again, I'm only looking at the bases of the tree here. So I look, oh, this guy's got a 2, so does this guy. So I write 2. What else do they have in common? They got a 5 in common. What else? Oh, just look at the bases. They got another 2 in common. Do they have anything else? Go ahead and multiply those guys together. What's 2 times 5 times 2? We get 20. So we have what we call a GCF greatest common factor of 20. Both of these guys, 40 and 20, are divisible by 20. Okay? Yes?
I have a question about A that we just did.
Uh-huh. This one or the one above it?
The one above it.
Yeah.
The one that you sent to a circle with the final answer was 3 times 3.
Mm-hmm.
Can we not write that as 3 squared?
You could write this as 3 squared times 5. I just left it all, but I do want you to write out your variables. So the question is, can we write this as 3 squared versus 3 times 3? Yes, you could do that. But variables, I do want you to expand those out. Good question. Any questions on number 4? Yes, sir.
So, I don't know if this is a dumb question, but.
No questions, dumb question.
Okay. So, you see where the 6 is, the how this is 3?
Yep.
What is the 3 though?
So we're looking to see what does this guy and this guy have in common, right? So this guy has a 2 and this guy has a 3. They don't have anything else in common. They don't have those in common. Now, if this guy had a 3 and this guy, then we would take that as a common factor. All right, so good question. All right, so let's try it again. Let's look at 64 here. Okay? So 64. Now, some of you guys know what the greatest common factor is. You know what these two numbers have in common or what they're both divisible by. Right? Some of you guys know this right away. That's awesome. Some of you don't. Okay? What do you think it is? Yeah? 16. Are they both divisible by 16? Not sure. Some people might think it's 8. Some people might think it's 2. Well, let's find out. So I take 64. All right, let's break down 64 to what? 8 and 8. All right, so you want to keep going? We got 4 and 2, 2 and 2. Right? We can break down this 8 to 4 and 2, and that's 2 and 2. So far, so good? Now we got 80. Break down 80. What do we got for 8? We got 80. Let's break down 80. What do we got? 8 and 10. Perfect. We got 4 and 2, 2 and 2. And we got 5 is 5, or 10 is 5 and 2. So I broke this down all the way, and now I'm looking for prime factorization, right? What do they have in common? Right? So we take a look. We're not looking at, if I broke down 4, I don't want to look at this 4 and this 4, or this 8 and this 8. Those guys are gone. We broke those down already. Just like I broke these guys down. I'm looking at only the bases of my tree, my factor tree. So I see a 2 and a 2. So I write that one time. What else do they have in common? Another 2. Okay, don't look at that 4 because we broke that down, so we're kind of can't look at that. You gotta look at the numbers beyond it or underneath of it. We got another 2 in common. Look at that. Anything else? There's another 2. Oh my gosh. And then that's it, right? This guy only has a 5 left, and this guy has 2 2s. So they don't have anything else in common other than 4 2s multiplied together. What's 2 times 2 times 2 times 2, or 2 to the 4th? 16. Both of these guys are divisible by 16. Okay? So if I take 64 and divide by 16, that's 4. If I take 80 and divide by 16, that's 5. Okay? Now, do you have to break it down all the way is the question I always get. Heck no. If I have 64 and we broke it down to 8 and 8, and you had 80 and you broke that down to 8 and 10, right there, I got a pair of 8s in common. Right? Right? And then, okay, well, 8 and 10, I need to break down a little further. That's 2 and 4, right? And what's 10? 5 and 2, 2 and 5, right there. Look at, I got a pair of 2s. And now that's 16. Now, if I try to break down 4, that's 2 and 2, and that's 5. There's nothing else in common. Okay, so again, you don't have to break it all the way down unless you want to. Okay, do it again. 64. Maybe you broke it down to 16 and 4. And then you had 80, and you broke that down to 16 and 5. Well, shoot. I got my 16s right there. There's nothing else they have in common. 16. You don't have to break it down all the way if you're looking for a greatest common factor. Okay? But this will help you if you are really struggling with finding that common factor, break down all the way down to prime factorization and then just start circling the bases, what they have in common. All right? All right, so let's do it one more time. Now we're going to look at variables here. All right, so we got 40 a squared b. Yep, that's right. We got 40 a squared b, and then we got 48 a b to the 4th. So first off, let's break down 40, y'all. 40, 40. 10 and 4. We're going to do prime factorization. That's 2 and 5, 2 and 2. A squared is A and A. And then B is B. Now we got 48 A, B to the 4th. 48. What is that? How much? 6 and 8? You might have done 4 and 12. You might have done 2 and 24. It doesn't matter. So I'm going to break this guy down 2 and 3. That's 4 and 2, 2 and 2. A is A, B. If I write out all these B's, I got B, B, B. I got 4 B's. O, N, G. All right, we start circling. What do they got in common? Tell me one thing. Let's do the numbers, 40 and 48, looking at the bases here. What do we got? We got 2 in common. 5, no 5. Ooh, I got another 2. I got 2 2s right now. Ooh, I got another 2. So far, so good. A's. How many A's do they have in common? They just have 1. This guy has 2 A's. This has 1, so they only have 1 in common. Let's write that guy one time. And this guy has a B, and this guy has 4 B's. Well, they only have 1 in common. Final answer, go ahead and simplify. 2 times 2 times 2 is how much, guys? 8 A, B. So we would say the greatest common factor is 8AB. And if you look, both of these guys are divisible by 8, right? 40 divided by 8 is 5. Get it so you can see it. So 40 divided by 8 is 5, and 48 divided by 8 is 6. Well, 5 and 6 have nothing in common. That's the greatest common factor. And then add in an A and a B. No.
So how did you get this when, like, if you do it a different way, like just 2s,
Yep.
you get like 7 2s.
7 2s for where?
Like if you go by dividing things by 2.
All right, so you had 40. So let's just go through. You said divide by 2. That's 20. Divide by 2. That's 10. Divide by 2. That's 5, right? Then we look at 48. Divide by 2. That's 24. Divide by 2. That's 12. Divide by 2. That's 6. Divide by 2. That's 3. But then we look to see what they have in common. This guy has only these 3 2s with these 3 2s. Right? This guy has a 5, but this guy doesn't. This guy has a 2. There's no more 2s to circle. This guy has a 3. This guy doesn't. So again, it's 2 times 2 times 2, which is 8 for that guy. Okay? Again, they have to have the same for them to be in common. They have to be overlap. Kind of like a Venn diagram, right? What do they have in common versus what they don't have in common? Making sense or not making sense, y'all? All right. So I got 18x cubed 6x. Do you have to do a factor tree? You don't have to. If you know 18 and 6 are divisible by what? More. They're both divisible by 2 and 3, so that means they're divisible by 6. So if you know that they're divisible by 6, you don't have to do the factor tree. I know right away that the answer is 6x. If you're somebody that doesn't see it, then factor tree it. 3 and 6. Oh, 3 and 6, I got a 6 right there. Right? X cubed is x, 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 and now I have an x. I can only circle one of them in common. So final answer is 6x. Okay? Ladies and gentlemen, that is it. That's all I got for greatest common factor. If you need those factor trees for GCF at the end, then go ahead and do it. If you see the factor right away, then go ahead and do it. But double check with your calculator. Make sure they're both divisible by that number. All right.